Right. So what we're going to talk about today is sort of some patterns, just a light pattern talk to get you into, just essentially expose you to other ways of thinking. So this talk used to be called architecture talk, and it's sort of somewhat on architecture still, but it's also many game object patterns, and sort of improvised as soon as I get to the end based on what you people want to hear. But yeah, so sort of the scope of the talk is first some words of warning, then game object systems, discussing an object-oriented solution, components, ECS, and the communication problems that can arise from those. Then we might go and look at my graphics exam, since you are sort of going towards the exam, and also exam tips. So yeah, so we're starting with the words of warning. First of all, how many here are familiar with programming patterns? Is there someone who can define them? Or sort of what do you think of when you hear programming patterns?
Structure, approach, so a generic solution to a very well-known problem. You can use it as a baseline to, tweak it to your own.
Yeah. Cool, that's great. And do anyone know of any patterns?
I don't like the term master-slave pattern, the singleton.
Yeah.
Singleton pattern. I know of several more.
Yeah. Cool. So yeah, for those who don't know patterns, essentially they are, as I said, that it's sort of generic solutions to problems that has been solved before, and the sort of good aspects of them is that they can really help reduce complexity, they help to reduce complex problems, and also they can help programmers communicate, because if I have a specific problem and I implement a specific pattern, and you are familiar with that pattern and also familiar with sort of the problem that that pattern can solve, then you also sort of almost instantly know more about the solution. So it's sort of a way to establish terms. Yeah, so these are all really positive sounding stuff, but I call the slide words of warning. And because of that, we're going to sort of play a game, or I'm going to show off a game. But first I'll show off a book, so this is a book called Game Programming Patterns. It's a really great book covering patterns, especially those that can be used in sort of a game programming context. I would advise you all to read up on them, because a good thing about this book is that it's actually available for free from the page of the author. So if you just go to gameprogrammingpatterns.com and scroll down to web, then the entirety of the book is available sort of in the web page. So you can just go to a component, and then you still get sort of the whole book with all the illustrations, etc., etc. So yeah, so I was first introduced to sort of patterns, and I guess more also abstractions when I finished my first year here in Gjøvik and went on to work at Kongsberg, where we spent a lot of time thinking about sort of the architecture of our solutions and trying to create nice decoupled systems that can be reused and that's sort of clearly defined in abstract senses, and not having to worry that much about the details, etc. And when I then finished there and sort of got this book, it was really cool because there are so many patterns in here, and obviously they're all great. So I got very enthusiastic, and when it came time for our first game jam, which we had in our third semester, we created this game called Both the Programmer, which is essentially just a normal side-scrolling game, and it, we spent 2 days on it, and it has this beautiful cutscenes, etc., which we drew by hand, of course, about programmers being stressed. And I just sort of want to simply show off the sort of functionality. So we have slideshows, we have a menu, you can, as soon as you start, you can walk around. So yeah, you can walk around, and then we have this cool, like, you get stuck in wild true loops because you're a programmer, and the way you get out of them is that, you jump on the magical break. And then we have staplers running around, which looks like big lips, and we have animations on the characters, etc., etc. But in general, this isn't actually particularly advanced. Like, the game is pretty simple. Some of you probably have an idea how you would sort of implement something like this, especially when we sort of wrapped it around as a funnel. So yeah. But when doing this project, I have just picked up this book. So obviously, we had to sort of go all out. I had to test all those patterns. So, I sat down yesterday and actually drew the architecture for this program in sort of not proper UML diagram, but in sort of my own version. So just before I show the picture, the dotted lines that you will see in the picture, dotted lines with arrows, means that sort of the thing with the dotted line is has a member variable of the type that is pointed to, while the thick line means that we are inheriting from what's being pointed to. So yeah, simple game. I wanted to sort of be a good programmer and abstract stuff and use patterns, and this is the architecture that I ended up drawing yesterday. So we have our abstract I entity, which is an interface on the top, and then obviously we have an entity that sort of implements the I entity interface, which are then subclassed by drawable entities, which no one subclassed from drawable entities. We have mobs, which are essentially everything else in the game. So the stapler, the while loop, the player, the semicolon, etc. Interesting enough, even though they don't inherit from drawable entity, they are also drawable. So obviously they were on screen, so there's some duplication going on somewhere here. The cool thing is that there's some people or some sort of classes that has collections of drawable entity. Even though if you go and look at the drawable entity class, we'll see that none of its functions are implemented. They just call the base class entity function, because we sort of halfway through the system went like, okay, are we ever going to have entities that aren't drawable? No. Okay, well then we might as well implement the drawable logic in the entity class, which means that there's no reason for this to exist. It just sort of went there. And then everything has pointers to delta time for some reason, because parameters and functions are stupid when you can just send stuff in. And everything has pointer to the renderer. So that's essentially a global variable that we decided shouldn't be global variable, because global variables are bad. So instead everyone has a pointer to it. So it's still global, it's just hidden. Yeah, so everyone has a pointer to a collection of the tile, or a collection of tiles. So which essentially means that everyone has a pointer to the internal representation of the map, like the 2D map. So yeah, and then we also have, here's where the sort of more patterns come in. We have our I state, which is, as a player you can be in different states. You can be sort of walking, crouching, or jumping, or well, you can be on the ground, in the air, or crouching. Which obviously they have to be implemented as a finite state machine, because that's what they are. And there's this great pattern called sort of state pattern that they can use to implement this. And then yeah, we have all our scenes, which all inherit from a nice scene-based class. I think my favorite one is the subscene or the cutscene scene, which is for scenes that are cutscenes. Which essentially all of these sort of turn into command patterns because they don't hold any extra states. They just have functionality. So in essence, there should have just been functions, because they don't really do anything that sort of implies that they should have been something else. But, so when I showed off the game, you know, with its simple functionality, how many of you were expecting that that sort of clusterfuck would be the architecture behind such a simple thing?
Because all of mine look the same way.
Okay. Yeah. Which is, you know, interesting. And the funny thing is that there were almost more patterns in here, because obviously I wanted to do a command pattern for the controllers, so that, you know, we would have rebindable controllers without having to actually do anything, so that we could just, you know, give them different function pointers to the different functions that should be executed based on which button you click. And then we would have an input manager that would have a sort of, basically a collection of commands in the command pattern, which obviously the player would have an instance of an input manager. Unfortunately, that didn't make it, or fortunately, I guess I should say, it didn't make it into the game, because I sort of ran into a problem that I couldn't solve in that pattern. And then the person who I was working with ended up just tossing the pattern away and solved the problem sort of properly. And I remember me going like, fuck, I mean, why are you doing it in that dirty way? It should obviously be sort of done with this nice pattern. So I remember being sort of, not angry, but a bit sort of disappointed that, you know, we were ripping out this awesome thing I made that wasn't even working. But looking back at that now, I'm just going like, you know, this is like batshit insane. I'm sort of almost ashamed that I at one point thought that this was great. Or at least in the before, obviously it was a game jam, so it would have been hacked anyway. But sort of, you know, it's, yeah. So that's sort of what the words of warning are. That, you know, patterns are, they are quite amazing, but they are also very easy to get overly enthusiastic about, you know, as seen there. We might actually, as time allows, we might actually jump into that code base and see, you know, what the great thoughts behind this was. Well, we'll actually do that right now, because I'll show the other aspect, which is, if we go and look to our entity demo, if I can just find my solution explorer. So if we go to our entity class, you'll also see that there that like, well, I don't know how much you actually see.
Is it totally impossible to see anything from back there?
You see lines.
You see lines.
Right. But is it because of the size or the brightness?
Contrast mostly.
Right.
Okay, let's switch it to blue. Is that better?
Yeah.
Cool. Yeah. So here also is where sort of everything goes wrong. Just like in general, please don't write, you know, inline virtual const get position const no except override final. On like every single, because, you know, it's almost like I've sort of lost track of what actually happens here. I just know that there's a lot of blue stuff, and at that time blue stuff was great. Now that I've sort of gotten more experienced, I would say that sure, that blue stuff is usually sometimes great, but, you know, most of the time it's just noise that no one gives a shit about, and it really gets in the way. So yeah, but yeah, going on. So so you know, here you can see our you know, static float pointer. So even though we say that it's not global, it's also global in the fact that it's shared amongst every class, so it is essentially global. But going for such stupid architecture has many different problems. Like, let's for some reason pretend that I would like to multi-thread this shit. I don't know anything about how essentially anything works, because it's just a big blob of interconnected lines. So yeah, patterns help reduce complexity, except when you're sort of overly enthusiastic about them. The problem sort of comes down to that when all you have is a hammer, then everything sort of looks like a nail. So obviously the correct solution is to hit everything. And while patterns can reduce a lot of complexity, they also add a lot of initial complexity, so it's essentially a trade-off. It's sort of going like, are your problem complicated enough that you can justify introducing sort of an extra level of complexity, because you know the complexity of the solution that you have now will continue to rise. So it's sort of like complexity theory in algorithms, that n log n algorithms are great when you are working with data sets that are large enough that it scales sort of better than n squared algorithms, for instance. So yeah, your problem needs to be complex enough to warrant it. And abstractions are good, and this is more general, not just pattern, but they are good as long as they fit. And with that sort of comes this sort of fun, forgot to say it, but the sort of fundamental theorem of software engineering, which is all problems in computer science can be solved by another layer of indirection, except for the problems of too many layers of indirection. Also, that quote there is very often sort of misquoted as saying that it can be solved by another level of abstraction, which is something else. But yeah, so that's sort of the issues you can get into with patterns, is that they might hurt you more than they actually help you. So you really need to be sure that that's what you want, and that your solution actually warrants it. And it is that sort of decision can be really hard to take at times. It's often super sort of interesting to try to sort of put patterns into or force patterns onto a problem, because it just looks so nice the way they're presented. Particularly that game, the main function of that game is just like create a game object and call game.run, and then you return 0. So you get the most beautiful short code. But what it really is, or what it quickly can end up being, is just a way to sort of hide a bunch of ugly architecture. So with that, we're going to talk about game object systems. So essentially game object stuff. So there are different approaches that you can take. You can put everything in one class, and that works for small projects. So it might work very well for your cases. We actually did put everything in one class in our graphics exam, I think. I think we just had a general purpose scene object where we just attach a bunch of different stuff, and everything was a scene object. Or you can do the inheritance-based approach, where sort of everything inherits from a game object. So you can have different subclasses based on what sort of properties they're supposed to fulfill. You have drawable game objects, you have AI-controlled game objects, you have physics game objects. However, then you quickly get into this problem that if you have, how do you sort of create an AI-controlled game object that isn't drawable? Or how do you create an AI object that isn't affected by physics, assuming that you're sort of doing linear inheritance, or single inheritance, because usually multiple inheritance is not a great idea. But yeah, so you get into issues of duplicated code, as you saw in our example, that we have both an entity that was obviously drawable, and we also have a subclass of that called, drawable entity. And the problem that you can quickly get into when doing this inheritance-based approach is that certainly, or after a certain amount of time, different functionality starts to sort of boil to the top class, because you at some point figure out that, hey, most of my items needs to be drawn, or most of my items has a collision box, so I don't want to. I might as well just put that in the base class, because that's the sort of common approach. So with that, we're going to pick up another game, because we're going to look at how solutions or how components can help you structure those solutions. But first, we're going to look at the problem itself. So this is a simple game that is essentially just, we play the green square that's moving around, and we can eat circles, and then you have 20 seconds to try and eat as many circles as possible. Not particularly complicated stuff. So the way that it's implemented now is we've gone for sort of, and obviously as everything else, examples are essentially always going to be contrived. So this also is a contrived example. But in this case, we are sort of went for an object-oriented or inheritance-based object-oriented approach, where we sort of have our game object base class, which has a position because everything needs a position. And then it has an update method. It has a way to get the position and a way to set the position. Which, sort of a side note here, if you're only supplying get and set positions, you might want to consider whether or not that, and the only thing you're doing is to sort of set or return those positions without any sort of validation. Might be an idea to consider whether or not that should actually be public instead of sort of being private, but essentially still exposed. So yeah, we need squares because we have squares in our game. So we add our sort of square shape class, which is basically the same as the shape. It has a radius, which just makes sense for a square, but that's just because we're using that radius to check for collisions, and I didn't want to do sort of box collisions. So we'll pretend that this, yeah, they have a square shape has a circular hitbox. But yeah, they can be drawn, and you can get the radius, and then we have hold on, square shape. Oh yeah, yeah, and then we have a player, which is the square, so it inherits on a square shape, and the player has a score. And the player can move, so if you press stuff, then the player moves around with the with set speed, and you can increment or decrement the score. And you can get their score. And then we have what should sort of be eaten, which are the circles. So we have a circle shape, and they can be drawn. And then we have random colorable, which is essentially that we want our game objects to change color randomly. And obviously that's, in our case, it's just circles that should sort of randomly switch colors. And I think that's the final class, which is the edible one, which is the stuff that is random colorable. And those are, again, circles, so if you crash into them, or if the player crashes into them, then they are supposed to be deleted because they have been eaten, and then we increment the player's score. And then we also have stuff that is moving and is edible. Yeah, so as you can see, sort of, yeah. We have, suddenly our designer shows up and asks us, hey, you know, we only have circles as enemies in our games. We want a square enemy as well, sort of a square thing that can be eaten. And sort of finding a way to implement that into the system in an easy manner is not really, that's really hard, because that means that all of this edible stuff that, you know, derives from colorable, that derives from circle, means that we have to either shift around our entire inheritance hierarchy, or we need to duplicate code. So everyone sort of sees the problem with that approach, or at least the limitations. Cool. So there's one pattern that can sort of help us here, which is called the component pattern. And essentially what that does is that it avoids inheritance that brought up the sum. I think that's sort of, or that specific saying is from the game programming patterns book. And essentially what we want to think is, instead of creating game objects by sort of defining their behavior, we want to be able to add behavior to them. And then the components are sort of the encapsulation of that behavior. And then to create a game object, we simply just have sort of an empty game object, and then we attach everything, or all the different components that makes up that game object. So to sort of show that example, if we go here and then just comment out everything. So what we can do instead is that we say that we have our sort of base class I component, which is just an interface, and every component has a certain type, which we've defined in the component type even up here, which we basically just use to identify them, so that we can ask for different components from the game object. And then all components can sort of have the draw functions called on them, same with the update and initialize functions. However, they don't necessarily need to do anything. So yeah, and then our game object is essentially just, in my case, a position and a radius, and a collection of components. So a collection of pointers to I components. And when we create our game object, we essentially just say what its position is, how big it is, and give it a list of all the components. And you know, upon update, we iterate through all the components and call update on it and give it the information that it needs. Same on draw, we iterate through all of them and sort of call their draw function. And what we can do is that we can go and ask a game object to get a specific component, and then we supply the type. And then we iterate through all the components, check whether or not they are of that type, and then return them, or return a null pointer if we can't find them. Yeah. And then we just define the different components. So we create a square shape, which is one type of component, which is a color, and we draw it by sort of creating or setting the radius, or getting the radius from the game object each time that we actually want to draw our object, and which means that we quite easily can allow ourselves to change the size of the object. And same with the circle shape and keyboard controllable. So essentially every game object that we want to be able to be controlled by the keyboard, we can just supply them the keyboard controllable components. So the cool thing is then that what I've done is essentially create a lot of helper functions to just create game objects that sort of fits the needs I have at the moment. So for instance, we have the make player, where we say that, okay, a player is a square shape, or a player is a game object with a square shape that is keyboard controllable, that can collide with walls, and that has a score. And that's sort of what defines a game object. And similarly, something that's movable and edible is something that has a circle shape. It has a random movable component, it can collide with walls. It also can be sort of random colorable, and it's edible. Which means that, so the cool thing about this way of thinking is that if I want to, say I want a demo mode where the game essentially plays itself by just moving around randomly, instead of sort of trying to fit that model into my class hierarchy, I can just say that, okay, you know, I won't give you a keyboard controller or a keyboard controllable component, I'll give you a random movable instead. So, you know, if I run the game now, then after a while, that sort of pink square should start moving on its own. Yeah. Cool. So, everyone sort of understands that?
But if you can't control the square, what's the purpose of the game?
Well, this was just
Oh.
well, so one reason for doing it that way, this is sort of a contrived example, but for instance, on all the, I think that's also the example used in the book, that on other systems like on PlayStation 2, etc., I think you were, if not required, strongly encouraged to have a demo mode in your game to avoid burn-in on the screens, so that if the game wasn't active for a certain amount of time, then it would essentially start playing itself in a demo mode. And that's a way to sort of easily introduce that functionality, because what you essentially just do is start the game normally, just instead of saying that you want to have a sort of gamepad controllable component, you just give it the AI controlled components, and then the game still acts the same way.
Yeah, that makes sense.
Cool. So, any questions? Does everyone see sort of how powerful this actually is? And like you can do, yeah, you can implement a demo mode in like a single by changing a single line of code. Because this is what we want, right? We want essentially languages, or we want our programs to require the least amount of work to change their functionality, and this is a great way to help achieving that. So this is a very object-oriented way of creating a component system, and it has like no model is going to be, or every model should be adapted to your specific sort of requirements. So, for instance, we might discuss whether or not it's correct that the game object has positions or a radius, and that perhaps that should have been in a component as well. It sort of depends. In this case, the reason I choose to actually put them in the game object is because a lot of the functionality, or a lot of the components needs access to that, and it would be from performance point of view, it probably wouldn't affect anything, or not affect much, but it's annoying if I have to constantly go and get sort of the position component through the game object each time I want to get access about or access in relation to a position. So that's essentially why I chose to put it there. Because I know, for instance, in Unity, when you create your game objects that has scripts, I mean, their model behavior model is a pretty good component system, but it also seems weird that you have to attach scripts to game objects, which means that technically you have a script which has a position in the world and a scale and all of those sort of stuff, and at least for me that's sort of a bit weird when you're talking about something that's pure logic. So there's always going to be sort of trade-offs, and you have to decide for yourself what the best approach is when you're implementing this. However, know that sort of the power here isn't in sort of copying this architecture. The power is in trying to approach the problem in that line of thinking. Cool. So for you who are sort of, I would say that for your tasks, thinking in components could be a smart thing to do, or at least sort of having that mindset. There are negative sides with the object-oriented component system I showed you now, especially in terms of memory access speeds, etc. But for your types of problems, that shouldn't be any issues. If there's also something called an entity component system, which is what the new sort of data-oriented stack that Unity is working on is supposed to incorporate, which sort of takes this quite far, because what they essentially say is that they flip your whole mental model on its head and says that no, you don't have a game object that has sort of a component. You have lots of components that share an ID, and then a game object is sort of just a combination of, or an entity is the combination of the components that share the same ID. Which means that you're not really keeping stuff together anymore, it's more relational database line of thinking, really. And it's not impossible to do this. Just know that it isn't trivial. And there's always going to be, you really need to sit down and think about your problem from a lot of different angles to try and find the ECS model that works well for your case and that sort of performs based on how you want it to perform. But it's harder than it sounds. But you should know that it exists. So for your projects, unless you really want to delve into component systems, I would suggest going for a sort of more object-oriented component model. Or if your project is either small enough or that there's not that much variation in your game logic, just go for a sort of simple OO type system with just like a single scene object, for instance, like we did for our graphics exam. The sort of largest issue, at least in my opinion, when moving over to component systems, or components in general, but especially when you move over to ECSs, is communication. How do you how do you sort of ensure that all your different components with hash logic, or all your different systems, get access to all the data that they need? And there's sort of different alternatives to that. So for instance, in the one we took in the example that I showed, that the alternative I picked in the example that was shown was to say that communication happens through the game object by sort of accessing components, by getting them from a game object, and then calling methods directly on that game object. However, that comes with certain issues, which is that it's quick to introduce sort of order dependencies in when you update your game logic. So for instance, if we have an object that's supposed to scale you based on some amount of time, then let's say it scales you after 5 seconds, and the drawable component is sort of updated and drawn before you get to this time component that's supposed to scale you up, then you will be 1 frame off in when when the sort of scaled version of you is drawing. And in that case, obviously being 1 frame off in terms of drawing isn't a problem, but you might end up in situations where sort of the order dependency matters, and it leads to more interesting results and dependencies within your system. So sort of be aware of that you might need to think about which order that you're updating your components. And the communication is also implicit, in that you can't really see which components are talking to each other, because they're all talking to each other through the game object. An alternative is to say that you just have direct references or pointers to all the components that you need to interact with. The main problem with that approach is, again, it's sort of implicit who's talking to who, and also you can't move your memory around, and it's quite tightly coupled. Or you have message passing, which is essentially that you have some sort of event system or some other way of sort of sending off messages that can either happen this frame or, you know, before next frame. There might be different variations in when you want to fire off different events. The problem with that is that it's more complex. But yeah, that's sort of some ideas on the component systems and the communication problems. Any questions? You see why communication is hard? Cool, then I guess break?
Yeah, we can have a break now. So at what time do we continue? In 10 minutes, 15
yeah,
minutes? 10 minutes, okay.
So 3:15.
Cool.